scientists have developed a machine learning method that crunches massive amounts of data to help determine which existing medications could improve outcomes in diseases for which they are not prescribed. The intent of this work is to speed up drug repurposing, which is not a new concept. Think Botox injections, first approved to treat crossed eyes and now a migraine treatment and top cosmetic strategy to reduce the appearance of wrinkles. But getting to those new uses typically involves a mix of serendipity and time-consuming and expensive randomized clinical trials to ensure that a drug. The Ohio State University researchers created a framework that combines enormous patient care-related datasets with high-powered computation to arrive at repurposed drug candidates and the estimated effects of those existing medications on a defined set of outcomes. Though this study focused on proposed repurposing of drugs to prevent heart failure and stroke in patients with coronary artery disease, the framework is flexible, and could be applied to most diseases. This work shows how artificial intelligence can be used to test a drug on a patient, and speed up hypothesis generation and potentially speed up a clinical trial, said senior author Ping Zhang, assistant professor of computer science and engineering and biomedical informatics at Ohio State. Randomized clinical trials are the gold standard for determining a drug's effectiveness against a disease, but Zhang noted that machine learning can account for hundreds, or thousands, of human differences within a large population that could influence. These factors, or confounders, ranging from age, sex and race to disease severity and the presence of other illnesses, function as parameters in the deep learning computer algorithm on which the framework is based. That information comes from real-world evidence, which is longitudinal observational data about millions of patients captured by electronic medical records or insurance claims and prescription data. This is the reason we have to introduce the deep learning algorithm, which can handle multiple parameters, said Zhang, who leads the Artificial Intelligence in Medicine Lab and is a core faculty member in the Translational Data Analytics Institute at Ohio State. The research team used insurance claims data on nearly 1.2 million heart disease patients, which provided information on their assigned treatment, disease outcomes and various values for potential. The deep learning algorithm also has the power to take into account the passage of time in each patient's experience, for every visit, prescription and diagnostic test. The model input for drugs is based on their active ingredients. Applying what is called causal inference theory, the researchers categorized, for the purposes of this analysis, the active drug and placebo patient groups that would be found in a clinical trial. The model tracked patients for 2 years, and compared their disease status at that end point to whether or not they took medications, which drugs they took and when they started the regimen. Their hypothesis, that the model would identify drugs that could lower the risk for heart failure and stroke in coronary artery disease patients. The model yielded 9 drugs considered likely to provide those therapeutic benefits, 3 of which are currently in use, meaning the analysis identified 6 candidates for drug repurposing. Among other findings, the analysis suggested that a diabetes medication, metformin, and escitalopram, used to treat depression and anxiety, could lower risk for heart failure and stroke in the model patient population. As it turns out, both of those drugs are currently being tested for their effectiveness against heart disease. Zhang stressed that what the team found in this case study is less important than how they got. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.